Hello, everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the program manager of the Microsoft Reactor Toronto. I will share session resources with you in the chat. But before we begin, I'd like to quickly review two items, our code of conduct and event guidelines. First, please take a moment to review our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. This session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I'll be sharing the link in the chat for our YouTube channel. And if you've not been on a live stream through YouTube before, please note that you must create an account on YouTube in order to access and interact in the chat. You can set that up now. And if you have any questions but cannot use the chat, feel free to reach out to us through social media or on our website. Which brings us to today's session. We are on to the last session of discovering Azure OpenAI. Apologies for this little weird banner here, but I'm going to bring in our speaker here for today, Matt and Deepa. Hi, how are we doing today?
Awesome, thank you.
We're very excited for this session as we close with the series. So thank you again for being here with us today, and take it away.
Thank you, Alexia. So, hey, everyone, welcome again. This is Deepa Lakhani, and, full disclosure, if I sound a little funny, sorry, I'm under weather. I'm here today with Matthew Anderson. This is our last session for this particular series. So, thank you for participating across all these 4 sessions, and, a very warm welcome to everybody who's joining from different parts of the world. So far, we have done 3 sessions, and this is our 4th session on semantic kernel and prompt flow for beginners. So let me just advance my slides here. For those of you who are joining for the first time, I'm Deepa Lakhani. I'm a principal program manager coming from the engineering team. My role includes empowering partners, helping partners to accelerate development on Microsoft platform. And I have with me Matthew Anderson. Matthew, why don't you go ahead and introduce yourself?
Yeah, happy to. Thanks, Deepa. So Matt Anderson, I'm part of the application innovation team at Microsoft. So I work with customers in our healthcare and life sciences area, bringing intelligence into their applications at the field level. So excited to be on the session today.
Thank you, Matthew. I am joining from Atlanta, Georgia today, and let's dive in. So, as I said, so far I've done 3 sessions. The first one was on Azure OpenAI 101 fundamentals. The second one was prompt engineering. The last one was how to use Power Platform with OpenAI, ensuring the citizen developers can use AI Builder to build applications and workflow leveraging OpenAI. Now, this session today is more, for developers, architects, focused to learn more about prompt flow and semantic kernel. So let's start by talking about some of the challenges in building AI application, right? The first one that comes to my mind is crafting effective prompts, right? We need an authoring experience that allows us to craft prompts, create different variation of these prompts, because as you would have gone through prompt engineering, it's an iterative process. So you need to go through multiple variations, compare the outputs, and in order to store like different versions somewhere, you basically want to store somewhere, right, the different versions of prompts that you're creating. In my team, I know a lot of folks, we started using Excel and OneNote and Word documents to kind of maintain the different variation of prompts that the team was creating and collaborating on, right? While I proceed, talking about this slide, with many of you joining from different parts of the world, it would be interesting to see if you can put down in the chat window, what different mechanisms have you used so far to store and track different versions of prompts and collaborate, right, within your team, especially if you have team of developers or prompt engineers? How do you collaborate on the different prompts that you are creating? So for all these purposes, right, in order to basically work around these challenges, we needed an IDE. We needed something that was that would allow us to create prompts, collaborate, and share development, of course, create different variations, ground the LLM with your data, right? Integrate with other systems, right? Being able to write code and mix that with prompts, etc. So that's where our prompt flow comes into the picture. This is in public preview today. With prompt flow, users can create prompt workflows that connect to various language models and data sources. You can also access the quality of workflows with measurements such as groundedness to choose the best prompt for your use case. Prompt flow also integrates into Azure Content Safety, which is a new Azure AI service for content moderation. So haven't you wondered, excuse me, if I write a prompt or if I get a response, how do I make sure that response is safe, or the prompt that I'm receiving from the user is safe, in terms of different categories, whether it's violence or hate category, etc., right? So this new service, Azure Content Safety, allows you to do that, and it can be integrated within the prompt flow. It helps users detect and remove harmful content, and you can do that directly in your flow of work. You can create AI workflows that would connect to various language models, as I said, data sources. Also supports Semantic Kernel, LangChain plugins. And towards the end of the demo, we'll see one of those demos where we integrate this into like a plugin for Semantic Kernel. So next slide. All right, so this is, we'll see a demo of this, but basically shows on the right-hand side, shows the screenshot of what a prompt flow looks like in the Azure ML Studio. And then the capabilities overview. It allows you to, as you can see, there's a designer on the right side. So it allows you to develop flows that connect to different external data sources. You have different tools, such as LLM. You can write and craft your prompts. You can call your LLM model through connections. You will use runtimes to be able to, and computes basically, to be able to run these flows. And of course, you have a nice designer, a visual representation. So let's dive into it. And before we go to the demo, right, let's talk about like key concepts. And then in the demo, I'll show you each of these concepts. So the first one being connections. So connections plays a crucial role. It is basically a way to establish connection to a remote API or a data source. They encapsulate information such as endpoints, secrets, right? So which allows you to ensure that there is secure and reliable communication. Runtime, it is basically allowing you to serves as like a computing resource that enables you to execute your flows. Runtime is it's basically equipped with a pre-built Docker image, right, which is included in your built-in tools, and you would create one such image. You could also create your own custom environment by using this pre-built Docker image as a foundation, and then further adding like packages or and then basically publishing this as a custom environment in your Azure ML workspace. Prompt flow today, it offers two types of runtime. One is the managed online deployment, and we'll look at that. It basically creates an HTTP REST endpoint. And then the second one is this compute instance runtime, right? The next concept is a flow, and a flow is, basically in prompt flow, it serves as an executable workflow. So on the designer on the right-hand side, what you saw that's basically your flow. It contains series of nodes, right? And these series of nodes represent specific tools or like unique capabilities. Some of the tool, and then that segue into the tools. So tools, you can think of it as like executable units with a specific function. For example, in PromptFlow today, we have like a Python tool that allows you to write Python code and then execute that. You have an LLM tool, which allows you to craft a prompt and send that to the Azure OpenAI servers. And similarly, you have like a prompt tool again for crafting the prompt. And then lastly, very important but very useful feature variants. So as I said, going through prompt engineering, it's an iterative process. You need to try different things. You need to create different variations. So variants allow you to do that. It's, it refers to a specific version of a tool node, and that can have its own distinct settings. Currently, variants are supported only in LLM tool. So for example, I could write a prompt and then create a variant to send that prompt using a particular connection for a temperature parameter of, let's say, 0, or with a different prompt. Or I could create another variant where I would send the similar prompt to kind of test it with a different temperature or a different model. So you can do that and then compare the outputs for these different variants. Okay. All right, so let's go to the demo. Okay, so let's begin by, so this is my, and let me go here. So this is my Azure ML studio on my screen here. What you're seeing here, and is the prompt flows. As I said, this is in public preview. So let's look at the top here. Let's see if I can, yeah. So what you see here, let's start with connection. Actually, let's start with runtime. So the runtime here, and let's click on it. So as I said, today with runtime, it's basically a way, a compute, as I said, right, to be able to run your flow. So what I've done is, in my compute, I have a pre-built Docker image that I used, and I created a runtime here in my compute, and then I added that runtime here within the prompt flow. So what this means is this particular runtime is now available for me to be able to use in my flow. The second thing that I did was build my connections. So in my prompt flow, let's say I wanted to connect to Azure OpenAI service. So what I'll do is I'll create a connection to my Azure OpenAI service. And in creating the connection, it is going to ask me the API key, the API version, and things like those, right? Similarly, I wanted also to connect, let's say, to my Azure AI Content Safety Service. So I've also created a connection for that. I also have a default Azure OpenAI connection here. So let me just click on create here and show you. So as you see here, I'll zoom a little bit. So as you see here, the Azure OpenAI, when I say click on create connection, these are the parameters it is asking me for. It has a name, it's basically a connection name. The provider is important, right? So when you're creating, do not change that. For Azure OpenAI, it has to be those specific two words, Azure OpenAI. Then it is asking me my API key, API base, API type, and API version. Now, for those of you who haven't seen the first session, how do I get this information? If you have deployed your Azure OpenAI service, you could go to your deployment. If you click on view code, it'll allow you to, within Python, it'll allow you to see your API type, which is Azure. Let me just zoom this a bit. API base, which is your endpoint, API version, right? So you can get all of this information from here. Going back here. Okay, so that's how you'll create your connection. Once you have your connections here, you can practically start building a flow. And you'll be using these connections in your flow for different tools and nodes. So let's click on create. Okay. So what you're seeing here is there are three different types of prompt flows. Standard flow, chat flow, which allows you to send messages back and forth, and then there's evaluation flow, which is basically to measure, how well the output matches your expected criteria, more of an ML prediction kind of a thing, right? And then what they've also given us here, which is great for learning, by the way, is a gallery, right, which includes some sample flows. So if you're new to prompt flow, you could create, let's say, a Ask Wikipedia flow, a chat with Wikipedia, web classification, and kind of go through the different nodes, the different tools that are used. And it's great for, to get a jump start on learning this. So what we'll do is we'll start by creating a standard flow. All right. So when I create a standard flow on the right-hand side here, let me zoom that. This is the designer. It shows me I have some inputs on the top, and then there is a node called joke, another node called echo, and then finally the output, right? So coming back here, if you see, the inputs are nothing but the variables that you can create, that you want to pass, or input variables that you want to pass into your nodes, right? The second node here, which is, so that's my input node. The second node that you see here is echo, which is basically, it is trying to, it's just a piece of Python code, which is, just spitting out the input value. And you can see here, you can basically provide input variables. So in Python, when I say input is the string variable, that's the input this is expecting. And what it'll do is, when you click on validate and parse input, it will create this variable here, like an input variable. And what you can do is, you can then use the output of my previous node, right? Or the input variables that you created to pass it as my input variable. And finally, what you see here is LLM node, right? And this should look familiar for those who have attended the prompt engineering session. This is nothing but a prompt, and it's basically passed to my Azure OpenAI service, right? It says, the system prompt tells you, it sets the personality, it's a system message for your Azure OpenAI service that you are a bot and you can tell jokes. And then basically the user question. Notice here, this is how, with double curly brackets, this is how you will pass an input, again, a variable. And when you do that and click on this button, validate and parse input, it will create this node right here. And then in here, you can provide the value of that, the value that you want to pass into your topic, which is a variable here. Okay. So let's add a node here. So what I'm going to do is, I want to create a prompt flow. And I'll just show you a couple of things. I want to create a prompt flow that gets car feedback, and then I want to pass it to analyze sentiment, and then also probably extract a car model out of it, right? So what I can do is, let's create one more input here, and I'm going to call it car feedback. And we'll pass in some value, some string here. I'm going to pass some review that I have here. And I also had some content which I'm going to remove, which I had used to test my Azure safety. Okay, so that's my car feedback. And then what we can do is, the next step would be to create one more LLM node. So I'm going to click on LLM on the top here, and you'll see it creates this node. I can click on, just zooming this. So it created this LLM node. I can click on edit here to change the title. So I'm going to say analyze sentiment. Okay. And then for connections, now, remember we had created some connections. So there was a default Azure OpenAI connection, but this is the connection to my Azure OpenAI service. So I will select that. I'll select the completion model. And that's my deployment name, and it allows me to set other variables like temperature, etc., if you want to set them too, right? And for my prompt, I can say identify the sentiment, just like that, and say cannot determine if you don't, if the words are less. And then within the square brackets, here is where I want to pass my input, which is the car feedback that I'm getting, right? So what I can do is I can say car feedback. So I'm creating a variable here. And then when I say validate and parse input, notice what it does. So you see here, it created this car feedback variable with type string. And then now I can pass a value from my previous nodes, which was input car feedback. So, and let me go and delete this one. We don't need this step. I'm also going to delete this step. All right. So, and let's click save on top. Notice the runtime here. It's prompt flow test. And then I'm clicking, I'll go ahead and click run. And if the demo gods are with us today, this should show us the output.
Let's hope.
Well, maybe not, maybe they're not. So what I'm going to do is I'm going to show you this that I had created before, and let's see if this works. Okay, run anyway. Okay, there we go. Something happening. So you can see on the designer that it's running. Oh, yes, I know why. So, okay, so this is a good one. So you can see here in my car feedback, I actually tried passing a prompt, which included some, if you see here, some violence in order to test the Azure safety text. And it is failing because my Azure OpenAI service says that I can't request because it is not passing the Azure filtering. So that's actually good news. That means it did run, and it did what it was supposed to do. So let's do this one more time and run. Anyway, submit. Okay, so while it runs, I'm going to show you what the output could look like. Oh, there we go. Okay, so it finally completed and it passed. So we can see the output here. For my analyze sentiment, it's the same prompt, right? And we can see the output here. It says the output was positive. So from the feedback, it was able to analyze the sentiment of the car feedback. What I also have here is a prompt which tries to extract the car model from the feedback. And for that, what I've done is I've used few short prompting where I've given a couple of examples. And then I'm finally saying, hey, just try and find the model from this particular text. And what it did is when I run that, it is able to output the model, which is RAV4. So all in all, works great. And then later on, what we'll see is, so finally, before I hand it over to Matthew, very quickly, you can deploy this. We already saw the runtime here. So this is the first runtime, where I'm using compute. The second runtime, as I said, from here, you could actually create a REST endpoint, which is a managed runtime. To do that by clicking deploy right here. And when you do that, it will create an endpoint here, something like this. And now if I click on this particular endpoint, you can see I can actually test this endpoint right from here, from this JSON or form editor. And you see it ran beautifully. You also have a consume node here, which gives you the REST endpoint as well as a Python code. And Matthew will show this to you later. He basically used the C# code to call this into Semantic Kernel as a plugin. And finally, you also have some monitoring and logs. Basically, if your prompt flow is failing, you could use these logs and monitoring to kind of see what's wrong there. So with that, let's dive into Semantic Kernel. Over to you.
All right, thank you very much. So clearly, for those who have been following along since the beginning of this series, there's a lot that's different when you're working with these AI models from how, as a developer, you might traditionally work with development. Concepts that are coming up, even some things and questions that we'll cover in a bit of, starting with prompt engineering and thinking about these in a little bit different of a way. And with that comes a different model of how you can approach things as a developer. And Semantic Kernel is all about being able to help provide easier ways to get AI capabilities into your app without having to think very narrowly in your application about all the little intricacies and knobs that you might need to twist along the way in working with, with all the things that have been in these previous sessions. And really, it's a set of tools that can help you create things much faster that take advantage of these models. So, at its core, Semantic Kernel is an open source project started by Microsoft with the idea of helping be able to take common, programming languages like Python, C#, Java, and so forth, and give you tools to be able to wrangle the large language models as you want to work with those, and a handful of different capabilities around those that I'll cover as I go through my portion of the session here. But when we take a little bit of a step back from Semantic Kernel itself, we want to look at kind of where this fits as you think about developing applications. So here up at the top, you have your applications. It could be an existing application that you want to add AI capability into, or it may be a new application or an existing one that you want to work with, and you want to be able to leverage things like these common foundational models, like the OpenAI GPT models, for instance. You may also want to bring in things like your data and other infrastructure like prompt flow and a variety of different tools there. So we have this section in the middle of AI orchestration that is squarely where Semantic Kernel fits. And this idea of the Copilot stack is one that at Microsoft we've been using as a way to be able to describe the way that you can take applications and bring together those AI capabilities in a consistent way across your applications, and be able to do that in a very rapid manner. And when I'm saying Copilot, just to be clear, what I mean is not just like Microsoft's packaged products that we call Copilot, like GitHub Copilot or Microsoft 365 Copilot and Word or Outlook or those types of places. A Copilot is any place where you're trying to use that modern AI and large language models to assist you with complex tasks. And what we have in Semantic Kernel is kind of this future where we want to make sure we reduce the amount of technical debt that we're going to gather in trying to build this, because you can very try to quickly push a GPT feature into an application, but if done in a bespoke manner, it becomes challenging to continue to iterate on that. You think of some of the things in the previous sessions that we have here as you're going to continue to build out and develop more and more capabilities around the types of prompts that you have. You want to be able to have a paved path to be able to bring those things together. And there's more than just prompts that you want to do. Prompts aren't good for everything. Common example here is large language models are not meant for math. And you need a way to be able to handle that as you're working with math-based prompts in an application. Working with, building the context for those prompts, or bringing in things like, relevant additional information, having memory of different things in a conversation or in a context of a user or a knowledge base that they might have access to, where you want the prompts to bring in that context. And then orchestrating all that and having libraries of prompts. You need something to be able to help you with this. And that's really where Semantic Kernel fits into things. So if you think of Semantic Kernel as a developer, it's a way for you to harness those foundational models, whether it's Microsoft, whether it's OpenAI or other open source models, and to be able to provide a user experience on top of that that brings in things like that state, which OpenAI doesn't have a concept of state. It doesn't know from one prompt to another what you had said unless you have something helping out with that. That's Semantic Kernel in this case. The other one is this idea of side effects or plugins. We're going to spend a lot of time as I go into demonstration around this idea of side effects and making things happen. That is, people talk about, that's where the magic happens when you're working with AI. These plugins are the way to help make that magic happen and define what that looks like and put them in an order that makes sense to be able to get the right type of output that you're looking for in your app. So enough with slides, let's go into demonstration here. And for my demonstration, I'm going to do a couple of different pieces to it. The foundational one here, we'll do a sample of building a Copilot and following the pattern of the Bing chat extension in Microsoft Edge. And in this portion of the demo, what we'll explore is a little bit around those side effects and plugins and how they work with the models using that Copilot interface.
Hey, Matthew, before we go to the demo, we have some questions in the chat.
Okay.
So Julia Kastner asks, how long does it take to learn prompt engineering? How to start learning it, and do I need to learn Python before I learn prompt engineering? So Julia, I would encourage you to go in and listen on our second session, which is dedicated to prompt engineering. But no, you don't need to know Python to learn prompt engineering. In fact, you could also use Power Platform to build apps as a citizen developer. It's a low-code, no-code application integrating into Azure OpenAI. You do need to learn a little bit of tips, tricks, best practices with prompt engineering, and there is tons of material out there, resources out there, and the second session should give you that jump start. I think Matthew, the next question is for Jim M. What compute size profile are you using so we can expect a bit of weight when testing our code?
I'm thinking that one may be in response to the compute in the prompt flow. Yeah.
Let me see. Yeah. Well, I used the pre-built one that I had. I'll go back and check what was the size or profile. But so we'll get back to you on that. The next question is, this one is for you, Matthew. How is Semantic Kernel different from LangChain?
Yeah, absolutely. Great question. So Semantic Kernel and LangChain are similar in some ways in what they're doing. The idea, and we'll see this as I get into some of the demonstration, of being able to orchestrate a variety of different things in a chain, if you will, or orchestrate a series of things that are going to happen. Very similar between the two. One thing that I can call out specifically is that LangChain started very Python first. From a semantic kernel perspective, it kind of grew initially out of .NET, and we were using it inside of Microsoft applications. It also supports Python and has in the community Java developers that are working with it as well and trying to bring in some capability there. So similar tools. We'll see as we get into the demonstration how some of it fits together, and you'll probably see some of those similarities to things that you can do in LangChain. But great question.
Yeah, and thank you, Matthew. And for your question on the compute size and profile, Jim, I used 4 cores, 32 GB, 1500 GB storage, so pretty much standard one. But again, I'm not running what I created prompt flows are more basic, like Ask Wikipedia and chats. If you have certain services that you're planning to use in your prompt flow, which are like resource heavy, then you might have to increase that. So it's use case per use case basis. Yeah.
Great. All right. Are we good on questions, or shall I proceed?
I think let's get to your demo,
Okay.
and then we can take the rest of the questions after that.
All right, sounds good. So I'm going to start out. I'm going to pop open VS Code here, where I'm going to be working, and I'm going to work through a couple of interactive developer notebooks here. So the first one for you Python folks out there, I'll be doing some stuff in Python. For the second demo that we see, we'll flip over to a little C# for my .NET friends out there as well. So again, the demo that we're going through here is like, what if we wanted to build an add-on like the Bing Chat browser extension? And the first thing I'd like to do is just kind of look at it from a requirements perspective of what do we actually need to consider in how this works. So I have a screen grab here of the Bing Chat plugin, and one of the capabilities and where I'll start is to be able to compose some sort of text. So this is a little bit more on the rails of an example of working with a large language model, where as a user in the application, I'm being asked to provide a prompt. What do I want to write about? I'm choosing a tone, and that's a tone that might be predetermined here, or I could even add my own. So let's keep that in mind as we put this together. There's a format. Email is the one I'm going to focus in on for our demo here. And we can choose a length of short, medium, or long. So some of the very obvious things that someone's choosing. But also keep in mind, in this application, there's more than just what we see here. There's also the context of me as a user. I'm logged into my browser in this case, or in some other application. I might be logged in, and there's some context that can be used about who I am and what might be relevant for me. So keep that in mind as well as we continue through here. So how would we go about, working with this using Semantic Kernel? So I'm going to start by just grabbing some variables here based on what we saw up above, and I'll just store those in as variables. And I'm going to start bringing in the Semantic Kernel SDK. Again, here I'm using the Python flavor of this. And as I bring that in, I'm choosing, in this case, to use Azure OpenAI as the large language model that I'm using here. Now, it certainly also supports the standard OpenAI.com GPT interface if you want to use that. Here, I'm choosing this for the additional control governance capabilities that are afforded with Azure OpenAI. So I bring that in using some of the things we saw before, like the deployment, the API key, and so forth. And the next thing that we need to do from a Semantic Kernel perspective is we're going to bring in plugins and functions. So the idea in Semantic Kernel is that you can have this registry of different plugins. Those are the things, as we think back to that example that I was giving before. This is kind of where the magic happens, is within those plugins. And what I'm going to do is I'm going to pull some plugin definitions from, in this case, a local directory. They don't have to be local. You can actually use the plugin specification for OpenAI as well to be able to bring in plugins. But here I'm just going to use a local directory for demo's sake. And I'm going to bring in a plugin called the writer skill. And within that, I created a specific function called email reactor. Just calling out, it's the reactor example that we have here. And within that, what I'm doing is I'm loading in this definition of the skill that I'm going to call in my code a little bit later. So there are a couple of simple components to the definition of this. One of them is, think of it like the header definition. If I was going to be looking for across various functions and plugins that do things, what is this one good at? So this particular function is about writing an email based on the given information, and I'm defining some of the things that are going into it. Input parameters, what it should be about, the tone, the length, and the person, all those things that we saw up above. And then in addition to that definition, we have the prompt template. This is what's actually going to be passed to the large language model when we use this function. So in this example, let's write an email based on the given text, use the tone that we're passing in as the tone. It should be a certain length, and it should be from the sender, and then I'm passing in the prompt that came from the user in my front-end application. So as we follow that through, what we do is we build some context for Semantic Kernel using each of those inputs, the tone, length, sender, and so forth. And we call our email function, passing in all of that context, and we print the result. Now, I'd run this a little earlier, and it created what I think is a reasonable enough email. But let's go ahead and tempt those demo gods and see how things go with coming up with an example for us here. It took a little bit longer this time, 6 seconds, but it came back with, I think, a reasonable email, based on that information. It has the information about the person, what I wanted to do. I'm interested in follow-up. The tone, I haven't really looked at it that much, but it seems professional enough, and it has my name coming through at the end. So that's great. Kind of passing in that context and getting back out through that defined skill or that defined function, the type of output that I'd be looking for. And this, what we're seeing as we call this is a semantic function that we're calling. So for these plugins, there are 2 kinds of functions that we can work with. Semantic functions are those ones where we're calling out to a large language model with some sort of prompt that we're using or prompt template that we're using and getting back that text information. We're using that language interface to be able to do that. Now, for native functions, as an additional type of function in our plugins, those allow us to do other things. The example I'd used before was math. Large language models, you don't want them to be doing your math portion of a prompt that's come in. You want to use something a little more reliable for that than a large language model. So that's where you can use native functions for things like math or time, or being able to read from or write to some sort of a data store, or do a variety of other different capabilities within your plugins. So let's now move on to an example of another plugin and do a little callback to Deepa's demo that we had just a bit ago. And let's use this idea of a native function where she's already established all of the, kind of all of the prompt definitions. She's tuned it. She's evaluated it for safety and moderation and those sorts of things. And it's available for us to just call as a straightforward endpoint. So here you can see that I'm bringing in some of the same information around our kernel. So we're establishing that kernel. And I'm also bringing in, she had flashed up the example of where it gave us code for calling her endpoint. So here I've carried some of that code forward, and I changed things a little bit where instead of having all of the code where it's making the full call, just in a single cell here, I took the portion that actually calls that API and makes that live request, and I've wrapped it as a native function inside of Semantic Kernel. So I called that thing get pithy feedback, based on everything that she had put in there. And effectively, I have that available as a skill here. And I'm defining this one instead of from a library of skills. I've defined this one in line. And then kind of the final thing that we do here is we get the results of that pithy feedback from the data that was provided in. So it's the same prompt that Deepa had, and the result is the CRV feedback is positive. And again, we'll tempt the fates of the demo gods, and 1.2 seconds later, bam, we have the feedback coming back in positive from here. So we're using Semantic Kernel and its native function capability to be able to call out to that skill that Deepa has published out there. So let me, kind of wrap that first portion of the demo here and set up a couple of other concepts before moving on to the next piece. So let's bring in a little bit more of our plate of things that are available when using Semantic Kernel. Specifically, I'm going to bring in things like state memories and the idea of being able to use a planner, which is going to help us to determine which of the different functions and plugins we want to use to be able to get something done. And to be able to see that, we'll kind of extend our Bing Chat extension and the capability around that to use a more natural language user experience. So I'll pop back over here, and as promised, I'm going to go to the .NET example of this one. So, here, very similar to what we saw before, we're kind of bringing in the semantic kernel so that we're going to be able to use it in our code. And like we did before, let's take a peek at what this looks like in the end application as we deconstruct it. So here I have the same Bing Chat add-in, but instead of that more on the rails compose, I'm going to use the chat interface. And with the chat interface, people can type in whatever they want to. So part of the challenge in working with this is being able to parse out what is the intent of what they're looking for. And based on that intent, what are the things that my application needs to do to be able to make good on that intent and come back with something that makes sense. So here we can see that I asked for what Microsoft Reactor is and give me the answer in Spanish. And down below, we've got the details about Reactor that are coming through in Spanish there. So, how do you actually get from this type of question where we didn't know ahead of time that that was going to be the question? How do you get from there to a reasonable response for your user? And that's, again, where Semantic Kernel comes in to help, and specifically this idea of a planner. So for time's sake, I'm not going to go deep into the planner, but the basic idea of planner is you have these defined capabilities through your plugins and functions that are available to your application. And the planner helps you figure out which of those is relevant for accomplishing the task based on the intent of what somebody put in. So in our example, the planner that we the skills that we might use as part of our planner, again, the request was summarize what Microsoft Reactor is and give me the answer in Spanish. There are a couple of things that might come to mind on that. One of them is doing some summarization of something, Microsoft Reactor in that case. And then we might want to write something or use a translation capability in a writer skill to be able to do it. So I haven't told it that we want to use translation, or I haven't told it what kind of summary specifically to do, but I know these are the types of plugins that might be relevant for accomplishing the job. And that's where Planner really comes in, where we say we provide it that request that came in from the user, describe what Microsoft Reactor is, translate the answer to Spanish. And then we go ahead and we ask Planner to create a plan for us based on what's in here. It looks at the intent, and based on the plugins and functions that are available, it generates a plan and puts an order to it. And it's using a writer skill, and it has a 2-sentence summary. So it shows the 2-sentence summary to summarize the given text. And then after that, it's going to translate the input into a language of choice, which in our case is Spanish for this one. And that seems pretty good. So let's go ahead and execute this plan just in code instead of using the Bing example. So here we're calling that plan and saying, hey, chain those things together in the order that you've called out. I'm good with that plan, and go ahead and put the results of what that are into just into the console here. So as you see it, again, I ran it before, but I'll go ahead and run it live here as part of that as well. It's super quick, 0.2 seconds. but it's just a 2-sentence version of that, very very quickly summarized and translated into Spanish. So in addition to this, when we think back to the chat interface and things we have to think about around that, is chats are ongoing. You as a user expect it to understand what you were talking about 2 chats ago, 5 chats ago, 20 chats ago, because it's part of that context. So what this idea of memory allows us to do within Semantic Kernel is to be able to have a good way of working with memories. Because anybody who's started working with prompts, you can't just grow the size and send in your entire chat history with every single prompt, because you're going to run into things like token limits. And as a developer, I don't want to be thinking about managing specific tokens. I want something to help me to be able to do that management, provide the right parts of memory to the large language model, and I can focus on building out the capability in my application that I want to have. So in this example, I'm going to use a volatile memory store. So the example here is just kind of loading things into, think of it like a session memory for this particular chat that I have going on. And I'm just looking at time. I want to make sure that I leave some time for questions at the end. So I'll breeze a little more quickly through this. But I'm going to add a few bits of information into memory. And then using Semantic Kernel, I can have some of that information, that factual history, available within the context of the chat. And as we look at this, we can create some of that context, as we saw before, to be able to bring it in and bring in things like a relevance parameter here around identifying what's relevant in the context of a new prompt that's coming in. So we're bringing in that history and finally getting through, again, just trying to go quick for time here, the ability to pass in and have that chat experience. So we've defined how the chat's going to think of things like memory and bring that in. And now when I ask it, hello, I think we've met before, remember my name is, it accurately remembers that the name that is in memory is Andrea. And then additionally, I want to plan a trip and visit my family. Do you know where that is? Yes, you said your family's from New York. Where do you want to, is that where you want to plan your trip? So it's already starting to bring those sorts of memories in. And I don't have to think as a developer around how I might do that with each individual call out to the large language model. Taking some of those things, being able to put it into a pattern and allow me to just think about the chat experience that we have on the front end. Last thing I'll show from a quick demo perspective is kind of the grown-up version of this, which we call a chat copilot. This is a GitHub repository that you can deploy as a sample using an Azure .NET application for the API and React front-end application that we're seeing here. But it's a simple chat application that allows you to see how some of these things come together. So an example here is, we have our Copilot chat that's in here. You can see in this example, I'm even uploading things like an employee handbook, which is giving some additional memory there and allowing the Copilot to help answer questions around that. Here I'm doing that upload to be able to give it some of that context. But behind this, we can actually see the detail of the persona, some of the meta prompting that's going on. What is in this concept of short-term memory and long-term memory that Semantic Kernel is helping me with? And am I going to bias things toward my short-term or long-term memory? Last thing in this one, just kind of as a teaser or fun, piece of this, is if you want to start looking at how the planner can help think through what you want to do. Here I have a few examples I've gone through where I wanted to send an email. And here is kind of the plan that it put together. And in this example, it's using not only the kind of native plugins that we have here, but it's also leveraging a plugin to the Microsoft Graph to be able to do the sending of that email. And you can think of these skills or rather these plugins and functions that you have as you make them available to your applications. There are lots of places where you might want to be able to plug into the Microsoft Graph or into a custom source or location that you or application that you want to be interacting with through a custom plugin. That could be your own proprietary data source that's only going to be available to your teams. So this is a great way of being able to see how you can work with those plugins, work with the planner, see the details around the plan that it actually puts behind those in a very interactive way. This is probably a few steps down the road. You don't cut your teeth on the Chat Copilot example, but I will when we get to the resources section. We have some available that are great starting points for being able to work with Semantic Kernel. I have a full architecture of a little bit more of what's what within Semantic Kernel, but I think I'll go ahead and pop open a thing with some resources here, and I suspect we might have some other questions that are available for us to follow up on. So I'll go ahead and pause and say, Deepa, did we have any other questions come in?
Thank you, Matthew. That was a great demo. We have some questions. I see one from Atomic Change. Is coding necessary to learn AI, or just a basic knowledge is enough? Well, this goes back to our, the same prompt engine sectors, if you will, right? So for doing something like semantic kernel or LangChain, what Matthew was showing, some coding is knowledge is required. But if you were to use Power Platform, if you were to delve into like prompt engineering, then you don't need really coding knowledge for that. I would encourage you to start with the Azure OpenAI 101 session and then go into prompt engineering and kind of start from there. How can we get started with Copilot plugin?
That broke up a little.
Do you want to respond to that?
Yeah, that broke up a little bit for me in the question there. It might just be me, but how do we get started with the Copilot plugin? So great question. I have up here on resources on the resources page a few different places that have this information available for you. Great places to be able to get started. The Chat Copilot example is available and deployable directly from GitHub at github.com/Microsoft/chat-copilot. That works with Semantic Kernel, React static web app, and a .NET service as the API. Another one is these semantic kernel recipes are a great way to be able to get started as well. Let me move my mouse so that's not in your way, but these step you through some things inside of the notebook examples that are part of the core semantic kernel repository. That's where I personally learned a bunch of this stuff. I'm not part of the product team that works on this, but I am a contributor to the open source community for it. So it's these types of recipes and in those notebooks where I kind of got my start in working with that. Additionally, just as a comment, all of the things that I used in my demonstration were adaptations or extensions to things that are in those existing interactive notebooks, either from the one that's using C# or the one that's using Python as part of that. So certainly a couple of great resources to be able to get going with that.
Thank you, Matthew. I had lost you for a bit, but I'm back now, just some bandwidth issues. Dr. Suman, question from Dr. Suman. Do you have any workshop sessions in SFB area where we could find out? I would suggest, I don't know if there are any in-person workshop, but I would say subscribe for the Reactor series. We have great sessions coming up on these series, I think every week, if I'm not wrong, or multiple sessions every week, I want to say. So yeah. Next question is
one other resource that I'll say from like a workshop sessions perspective. I would also take a look at the Semantic Kernel Discord community. Certainly, from a semantic kernel perspective, there are sessions, videos that are posted, as well as weekly office hours. But in kind of around that community, there are a bunch of people who are interested in leveraging large language models for development. So it's just another place that you can go and take a look for some of those resources, including identify some other people or maybe some other activities to get hands-on in a workshop type of environment.
Yeah, good call out. Thanks, Matthew.
Yep.
Next question from Challenge. Is there any connection with Bing Chat Enterprise? Can I use what you showed to enhance Bing Chat Enterprise? Well, I would say you could also build your own enterprise chatbot, by grounding your organization's data, right? There is a GitHub pattern out there. We'll see how we can share the link. But if you search, there are multiple resources available out there. How you could leverage Azure OpenAI, ground it with your own data, and then kind of use it as an enterprise chat application.
And additionally, one of the things I had shown when I called out the chat sample application, where you could actually see the various plugins that were available, that plugin concept becomes a really important one for being able to work with, some of these capabilities inside of other copilots. We're trying to leverage the spec for being able to bring in those plugins the same way that ChatGPT is from an OpenAI perspective. But as we start to think about how can we make sure that we have these things reusable and we're not having to stand up net new copilots all over the place, if people are already using a specific chat interface, how can we plug in some of that additional capability? That is the direction, at least that I'm seeing, around being able to use those things together. And you have that power of choice around some things that where you will want to kind of build in very specific capability into your application and have it be much more on the rails. You'll have other things where, hey, we already have a chat interface of some sort that's being used for something. If only we could add in like that send email capability with using Microsoft Graph or some of those other types of things where you just want a little bit of that, and that portability of those plugins becomes really, really powerful.
Okay, thank you, Matthew. Great question. I think we have answered rest of the question. There is a question by Michelle on, could you share the link to GitHub chatbot? I did paste. Alexia will paste that link in there. I think we have answered most of the questions. Oh, there's one last from Jim. What are the security terms and conditions for using LLM so that we don't expose proprietary data to data in an LLM outside of your control? That great question again. So that's where, OpenAI versus Azure OpenAI. When you use Azure OpenAI, you're basically bounding your prompts, the responses that you're getting, the data that you're sharing through prompts, etc., into those four walls. So with Azure OpenAI 1, you get that enterprise level security. Making sure that the prompts, the data that you pass through prompts, or the data that you use to ground your model is basically into your subscription in your tenant, not exposing it out. Also, there's whole different paradigm when it comes to prompt engineering on security, like prompt hacking, there are prompt jailbreaking. How do you avoid those? So there are good best practices out there, what you should do in terms of like general safety, making sure if you're building applications which are getting prompts from end users, how do you make sure that they are not hacking your prompts, or they are not doing content to kind of leak your prompts and expose information out of your prompts. So there are best practices, but to start with, you would use Azure OpenAI, which would make sure that the data is within those four walls with enterprise level security. Anything else we can add there, Matthew?
No, I think you said it, but I'll reiterate. Like one of the reasons that I showed the Azure OpenAI specifically in my example is that control that that many people want to be able to have over how that data is used. It's a huge concern for people, and one of the beauties of what we're providing is we're providing a platform. We are not. We as Microsoft are not training our foundational models or the OpenAI foundational model using any of your prompts as you're using or responses as you're using the Azure OpenAI platform. So, in addition to being, connectable to other, having secure connections to your data that lives elsewhere within the Microsoft cloud.
Yeah, great call out. So, all in all, any data or any prompt that you use there, we are not using that to train, let's say, GPT-5, right? So, your data is your data when using Azure OpenAI. So thank you, everyone. With that, great participation, and thank you.
Take care.